Lesson 8.3 Problem Set. In this problem set, you are going to find probabilities using the rules for mutually exclusive and overlapping. Don't do them in some other way, even though it is possible. You must use one of the rules for either mutually exclusive or overlapping. So first you must decide whether the two events given in any or question, and there may be other kinds of questions where you won't use that rule, but if it's an or question, you have to decide, are you simply going to add the two probabilities, or do you need to also subtract where they intersect? In this one, if I pick a number, can it be both prime and a 6 at the same time? If so, you need to subtract that in the end. Otherwise, you're going to find the probability of being a prime number and simply add the probability of being a 6. For the next one, you have a prime number or an even number. Again, you're going to take the probability of a prime number, add the probability of an even number, and then you have to decide, do you need to subtract being prime and even? Are there any outcomes with are both prime and even? If so, you need to subtract their probability at the end. You may use the Venn diagrams given here to help you in doing that. In the second question, you're going to look at a bunch of marbles that are in a jar. We want to find the probability of being green or yellow. We have a list of marbles here. Are any of them which are green and yellow? If not, we're simply going to add the two probabilities. If there are some that are green and yellow, you need to subtract the probability, and I mean green and yellow at the same time. You have to subtract their probability at the end. And the second one, we have a deck of cards. It says queen or red, so you need to take the probability of a queen, add the probability of being red, and then subtract any which are both queens and red. In questions 4 and 5, we're going to be looking at two-way tables. Remember that the outcomes in the table are the intersections of two things. These are the numbers of domestic and late. These are the numbers domestic and on time. These are the total number of domestic flights. These are the number that are international and late. These are the number of international and on time. These are just the number of international altogether. And then down here, this is the total number late, this is the total number on time, and this is the total number of flights. If we want to find the probability of being domestic or late, we need to find the probability of being domestic plus the probability of being late, and then subtract those in the table that are both domestic and late. Then I want you to find the probability of being domestic, and not late. This is simply a number that you're going to get from the table, divided by the total number, of course. Then I want you to compare the probability that you got here with the probability that you have there and see if there's any connection between them. See if you can discover another probability rule. Then we have another two-way table. We want the probability of headache or no medicine. Again, you must find the probability of getting a headache, find the probability of no medicine, and then find the probability of a headache and medicine. By the way, for each one of these, I need you to give me the outcome with some sort of symbols. For this one, how about we stick with headache and not headache, medicine and no medicine, and then use those when we write our probabilities. For the rest of the problem set, you are going to do the same sorts of things. You need to decide whether they are independent or not. I mean, not independent, but whether they're mutually exclusive or overlapping. Anytime there's an or event, which are most of them, because I'm trying to see if you know that there's a rule. So for the or, you're going to decide whether you're simply adding the two, that's when they're mutually exclusive, or if you somehow need to subtract, and that's when these two things have some outcomes in common. That will continue throughout the problem set. Some of them do not involve that. Like here, this is an adult. This is simply a probability that you're going to read from the table. The only time when you might need the table is when it says an and or an or. Well, an and will simply be one section from the table or more than one, and an or is when you're going to have to use one of the rules from the table. So this is the only or rule here. This two or more accidents is actually something up here in the table. This is 0 or 1 accidents. This is an or in the thing. You're going to have to add two things together. So this is a teen with a 0 or a teen with a 1. That's another way of looking at it. This is a teen with 0 or it's a teen with 1. Sorry, not an and here. This is the and part. They have a teen and a 0, or it's a teen with 1. And I'm not using any symbols here. You might want to develop symbols for them. You might use, for example, 0 and 1, and then say 2 for those. Or if you use teen and adult here, then switch to a different letter, like maybe W here. Again, for your events, so that you don't have to write these out in words, make sure that you're picking some sort of suitable letter for that. In the next questions, you again have another two-way table. Again, first put some letters for them so that you can write events, because for each one of these, I need you to write based on your events, whether it's an and or an intersection or just a probability. For this one, it says an and, so think of what symbol you need to put. This one just says it's from Parkville. That's a simple event. Said yes to recommending. Again, that's a simple event. This one, the customer was from Parkville and said yes. That's an and event. This is the customer was Parkville or said yes. That will require one of the rules from this section. And then I'm asking you to explain why you can't simply add the probabilities. For the last one, again, we have a two-way table, and you're going to look at the different things. Here, this is an or question. Make sure you decide whether the two things are mutually exclusive or not. This is another or question. This is an or question. This is an or, and this is an or. So for all of these, you're going to be using one of the rules, either simply adding the two probabilities if they're mutually exclusive, or making sure that you subtract any probability that was in the intersection of those.